Good afternoon. This is the homework check for Thursday, May 30th. And tonight we have 6 different word problems I'm going to run through. And our first one is a geometry problem. So we have Davis drew a straight angle on a piece of paper. He has decided to split the straight angle up into 3 different sections. He used a protractor to measure 2 of the 3 sections. The first section of the angle he divided was 70 degrees, the second was 45. How much should the last section of the straight angle measure? So here's what I did. I actually drew a diagram for this. So I drew in my straight angle, and I just started to kind of think about, okay, that's a straight angle. This is a right angle. So I just kind of estimated the angles. So I put that at 70. And then over here I drew a smaller angle, and that's 45. So what I'm really looking for is, I'm looking for this piece of the straight angle. What's missing? And if you drew the angles in a different order, the order really truly doesn't matter where you put them, as long as you put a 45 and a 70. So this is going to be a 2-step. So what I'm going to do is I'm going to start off with addition. I'm going to add the 2 angles that I've already drawn. So I'm going to go 45 plus 70 and figure those 2 angles measure 115. I know that a straight angle, the sum of a straight angle should equal 180. So I'm then going to use this 180 and subtract the 115. So I'm going to go 180 minus 115. Go ahead, work that out. So I need to borrow, since I have a 0 here. So I have 10 minus 5 is 5. 7 minus 1 is 6. The 1 and the 1 are 0. So this missing angle in here is 65. And if your model isn't perfect, it doesn't have to be. Mine obviously isn't. This is a little bit bigger looking than 65. It's fine as long as you get your 65. So that was our first problem. All right, our second problem says this. Dylan's writing numbers onto note cards. So far he has the numbers 2, 3, 5, 7, 11, 13, and 17. Miles is also writing numbers onto note cards, but he wants a set of numbers that is different than Dylan. So he wrote down 4, 6, 8, 10, 12, 14, 16, 18. What would be the next pattern in each number, and what characteristic could you use to describe the pattern? So here's what you have in Dylan's. If you look at the numbers in Dylan's, Dylan actually has prime numbers. And if you guys remember, this is something we studied way back at the beginning of the year when we did multiplication facts. A prime number is a number that you can only get in a multiplication problem by multiplying it by 1 in itself. So for example, 5 was on his list. So the only way I can come up with the number 5 through multiplication is by doing 5 times 1. Same with 11 being on the list. The only way I can get an 11 is by doing 11 times 1. So my list on Dylan's ended at 17. The next prime number would be 19. So the answer for Dylan is that his lists are prime numbers. The next one's 19. And then Miles, since he wanted something different, his numbers are composite numbers. Remember, those are numbers where there's more than one way to get them. So for example, he had the number 10 on his list. We know that we can take 10 times 1 and get 10, but we can also take 5 times 2 and get 10. So on Miles's list, his cutoff at 18, so the next number, you can't do 19 because that's a prime, so your next number would be 20. So the answer is one more time on 2, Dylan's prime, his next number is 19. Miles has composite numbers, his next number is 20. Okay, third question on your homework is this. Jordan's driving from Raleigh to Denver. She plans on taking 3 days to drive there and would like to drive an equal distance each day. The 2 cities are exactly 1,674 miles apart. How many miles will Jordan drive on the first 2 days of her trip? All right, on this problem, this is a multi-step problem. We're going to start off by doing division, because the first thing that tells us is that Jordan's driving, it gives us the mileage, which is 1,674. And it says that she's splitting the miles equally between 3 days. So we're going to take 1,674 and divide it by 3. So looking at this, 3 goes into 16 5 times. 5 times 3 is 15. 16 minus 15 is 1. I'm going to bring down my 7, 17. 3 goes into 17 5 times. That's 15. I'm going to subtract. 17 minus 15 is 2. Bring down my 4. I have 24. 3 goes into 24 8 times. And then down here, this is 0. So my answer is 558. This is the number of miles she drive per day. So if I look back at my word problem, it asks how much she drive on the first 2 days. So what I'd actually have to do to finish solving the problem, and this is where my second step comes in, is I'd either have to take 558 and add that up twice and get 1,116, or I could just simply take 558 and multiply it by 2 and get the same thing. So that is your third problem, and your final answer was 1,116. Okay, fourth problem. This is kind of a tricky one. It's a measurement problem, and here's what we have. A gas station in Gardner, North Carolina says that a gallon of gasoline costs $3.50. A gas station in London, England says that a liter of gasoline costs $1.50. What's the difference in price for a person buying 8 gallons of gasoline in both places? Remember that a liter equals a quart. So since this is in gallons, and this is basically in quarts, okay? If you think of your gallon guy, I don't have to draw very far on it to remember that there's 4 quarts in a gallon. So in order to get these two prices to be the same, I need to get them both to gallons. So I'm going to take the 150, I'm going to multiply it by 4. When I do that, I get $6. So an actual gallon of gas in London, England costs $6, which that's about right. And a gallon of gas in Gardner costs $3.50, which is close to right. And now what I need to do is I need to figure out how much it would cost to buy 8 gallons. So just looking at the $6 I found just a second ago, I can just simply take that and multiply it by 6. And I know that, or by 8, I'm sorry. And I know that the gasoline in England would cost $48. And then the $3.50 is a little bit trickier. If you don't remember with decimals when you're multiplying, basically what you can do is when you first start multiplying, you kind of ignore the fact that the decimal's there. So I'll show you to do with it here at the end. So you're going to go 8 times 0 is 0, 8 times 5 is 40, carry your 4, 8 times 3 is 24, plus that 4 is an 8. So what you can basically do with a decimal is there's 2 spaces here behind the decimal point, there's 2 spaces here behind the decimal point. So you end up with 28. So that's my answer for my cost of gasoline in Gardner. So now I have 28 and 48. I'm going to subtract them. And when I do that, I will find that the difference is $20. So my answer on number 4 should be $20. Okay, that was a tricky one. Measurement problems always are. Alright, 5 has a table. I'm going to put my camera on my table here and show you guys this. The Rand Road Track Club is meeting after school. 5 different members of the team ran part of a mile and then recorded their distance on the chart below. So I have Justin ran 75 hundredths of a mile, Alex ran 4 tenths, Tessa ran 8 tenths, Daniel ran 95 hundredths, Dominic ran 5 tenths. Which student ran the greatest distance? Which student ran the smallest distance? So here's basically what I do on a problem like this. All right, you've been given 4 numbers, and 2 of them are decimals, and 2 of them are fractions. So basically, or you've been given, 3 decimals, and 5 numbers. So basically what I like to do is this. I either pick fractions or decimals, and I convert them all so they're all the same. So I'm looking at like things. I prefer decimals, and that's just me. So like if I were looking at this, 4/10, I just write 4/10 as a decimal. If you'd rather do it as a fraction though, totally understandable. Okay, so when I take my fractions and I turn them into decimals, okay, my problem ends up looking like this. And then it's just really easy. And remember, when you're comparing decimals, you can a lot of times think about money. You know, you can throw that 0 on the end, and then basically you're looking at 75, 40, 80, 50, 95. This one's obviously the smallest. This one's the biggest. So your greatest would be, I think this is Daniel. Your smallest would be this one, which I believe is Alex. Okay? And if you wanted to see them as a fraction, all you do is, again, just get them so they're like things. So that first one would be 75 hundredths. This one that's 4/10, if you throw a 0 on it, you could write that. But you could also make it that, just so it's easier to compare. The 8/10, again, you can write it like this. Or you can throw the extra zeros on so it looks like this. The 5/10, again, you can write it like this. Or you can throw the extra zeros on and have it look like this so it's comparable. And then lastly, the 95 hundredths is like that. Okay? So if you were going to go ahead and add them up and try to figure out what the total was, what I would do, and I'll just show you doing the fraction part, is I'd go like 75, 40, 80, 50, 95. So I guess this is the decimal, or the fraction if you're using the hundredths, and I'd add them. So that's, whole column is 10, so I put down the 0, carry the 1. 1 plus 7 is 8. 8 plus 4 is 12. 12 plus 8 is 20. 20 plus 5 is 25, and then that's 34. And all of these are 2 decimal points. 2 decimal points. So this is going to be 2 decimal points. And so my total, if you want to find the sum, it's 3 miles, and either you could say 40 hundredths, you could say 4/10, or if you were doing a mixed number, it might look like that, or it might look like that. Okay, so last one here really quick, which is actually a mixed number problem. Seattle, Washington receives 5 1/5 inches of rain during the month of January, receives 3.5 inches of rain during February. How much more rain does Seattle receive in January than in February? So basically what you're doing is you're subtracting these. And so what I would do is I would take them and make them like things. You can make them tenths, you could make them hundredths. I'm just going to make them tenths today. So you ask yourself, how do I get from 5 to 10? You multiply by 2. So that 1 you have to multiply by 2. And then on the 3 1/2, it goes to 5/10, because you multiply by 5. 2 times 5 is 10. 5 times 1 is 5. Now, when you look down here, you have to borrow. You can't take 5 away from 2. Remember that when you borrow from your whole number. You look at your denominator to figure out how many are in a whole. In this case, it's 10. So I'm going to take this 12, or the 2, and make it a 12. So now I'm going to subtract my fraction. 12 minus 5 is 7. Bring my denominator over. That's tenth. That's a tenth. And then I can subtract my whole numbers. 4 minus 3 is 1. So my final answer for the last question is 1 7/10 is the difference in inches of rain. I hope you did well on your homework, and I will see you guys tomorrow morning. Thank you. Have a great night.